welcome back. So tonight we've got a pretty short homework, and what we're looking at is how to solve quadratic equations using square roots. So let's just jump into the problems. We've got a pretty short homework. There's only 6 problems here. I just kind of felt like after this, if you do all 6 of these, if you can work all these out, I could give you a million problems, but they're going to start getting pretty repetitive as far as how you work them. So that's a pretty good selection here. Let's start with number 1. I'll start by subtracting 5 from both sides here. So I'm using my properties of equality. And that way I can get the x squared isolated here. So after I subtract 5 from both sides, I get x squared equals 8. 13 minus 5 is 8. And then I want to try to get rid of that square root, and that square using a square root. This is sort of the whole focus of the whole lesson here. And so you can take the square root of both sides here, but you do have to remember to put a plus or minus in front of that square root. I'm going to say x equals plus or minus. And you have to do that every time you take the square root of both sides of an equation. So if you ever do that, make sure to include the plus or minus, the square root of 8. And that's pretty much your answer here. You can simplify this, but I'm pretty happy with this answer right here. If 8 was a perfect square, we could go ahead and evaluate that a little further. And like I said, you could simplify this, but I'm okay with that. Number 2 says 3 times z squared equals 48. So we'll start by dividing both sides by 3. Divide the left side by 3 and the right side by 3. And that'll leave you with, see here, z instead of x, so z squared equals, what would that be, 16? Yeah, 16 and 16 is 32. Yeah, okay, so 16. Now I'm going to take the square root of both sides, so I'm going to end up with z equals, again, can't forget the plus or minus, the square root of 16. Now 16 is a perfect square, so we can go ahead and simplify that further. The square root of 16 is 4, so we get z equals plus or minus 4. I'll put a couple lines here just to make this look a little nicer. Okay, there's number 2. Number 3 says 3x squared equals 8. So I'm going to, once again, just like the last one, divide both sides by 3. Probably take me longer to get this formatted looking nice than to actually do the problem. Okay, so I divide both sides by 3. And that'll leave me with x squared equals 8 thirds. Don't get scared off by the fraction here. It's not that big of a deal. It just means we're going to be taking the square root of a fraction. So yeah, here I'm going to take the square root of both sides, and that's going to leave me with x equals plus or minus the square root of 8 thirds. So not a very nice looking answer there, but that's what it is. Number 4, okay, we got to isolate this squared thing, so we're going to have to do 2 steps on this one rather than just one like we've done on the previous couple problems. First, I'll subtract 23 from both sides. Okay, that's going to give me 2p. You can already see something funky is going to happen with this one. 2p equals, what would that be, negative 8? Yeah. Then I'm going to divide both sides by 2. Going through the motions here. Oh, you know what? I forgot a little squared on there. Let's put that should be 2p squared. Either way, we're still going to divide both sides by 2. That's going to give you p squared equals -4. And take the square root of both sides, but as you can imagine, something kind of weird happens here because there is no real number who, if you square it, will equal -4. Because if you square a positive number, you get a positive number. You get a negative number, and you square that, it'll also be positive, which is why we have the plus or minus to begin with. But yeah, what is the square root of -4? Well, that's a good question here. So here's the thing: is for now, I'm just going to go ahead and say that there is no real solution, but I do want to show you what the solution is. So for now, I'll accept this as an answer: no real solution. Right? No real number that will be the square root of -4. However, what we could do is we could rewrite this as equals plus or minus the square root of 4 times -1, right? Because -1 times 4 is -4. And then we could take the square root of these individual factors here. The square root of 4 is 2. We have plus or minus, the square root of 4 is 2. And the square root of -1 is a number that we're going to call an imaginary number. Okay, so like I said, well, you could sort of stop here when you recognize you're trying to take the square root of a negative for now. But so that you can see kind of where this would go, this would be plus or minus 2i, where I equals the square root of -1. And we're not really going to get too deep into complex numbers in this course. I'm going to want to box that. So for right now, I'm comfortable with you just saying there's no real solution. There are two solutions here, plus or minus 2i. They're just not real numbers. I know it sounds weird, but we'll talk more about complex numbers in the future. Number 5. Now here we've got not just d squared, but d minus 1 squared. So even though we have an isolated d squared, we're still going to take the square root of both sides because we do have something squared that's isolated. So when we take the square root of both sides, we're going to get d minus 1 equals plus or minus -18. Now plus or minus -18, a minus is kind of redundant because either way you're going to have plus 19 or minus 18. I'm sorry, what did I say, 19? Positive 18 or negative 18. We really don't need that negative set there anymore. Now, what I would recommend on problems like this one is we actually split this up into two separate equations because we're going to have to solve them independently. So we have either d minus 1 equals 18 or d minus 1 equals -18. You can see how this problem is a little bit different than the ones we did before. Now in both cases here, we're just going to add 1 to both sides. Plus 1. We're going to have a bunch of plus 1s here. Maybe it'd be just easier to do this. Plus 1. Green. Good to stay consistent here. So we got plus 1 here. Plus 1 here, plus 1 here. We're going to add 1 all over the place. And we'll get our two solutions here, which are going to be d equals 19, because 18 plus 1 is 19, or -17. And there's the solution set for number 5. Six is the last one, and we'll solve this very similarly to number 5, but we do need to get that squared expression isolated. Even though it's got the plus 5, we'll take care of that after we do the square root. So first, I will add 1 to both sides here. And then I will get, so yeah, 8 plus 1 is 9. I'm going to have 3 times q plus 5 squared equals 9. Then I'm going to divide both sides by 3. Get rid of that 3. Divide that side by 3, divide this side by 3. Not sure what happened to my fraction bars there. Sort of disappeared for some reason. Right click something. And then, so now we have q plus 5 quantity squared equals 9 divided by 3 is 3. And so now we're going to take the square root. Now, square root of 3 is not going to be rational, so we're just going to leave that as plus or minus root 3. That's okay. We're still going to have two solutions here, and here's what they would be. So we'd have x plus 5 equals square root of 3, plus or minus, rather, the square root of 3. And then we want to subtract 5 on both sides. Now, you could have done, what I'm about to show you, you could have done over here, too. Like over here, I could have just write plus 1 on both sides, then have 1 plus or minus 18 and evaluate those separately. So I'm going to kind of do that same kind of thing over here, where I'm going to subtract 5 from both sides. I want to show you that, you can split it up. You don't have to. It's really up to you. So we get our solution set q equals negative 5 plus or minus root 3. Okay, so there are two solutions here, one with the plus, one with the minus. I'm just kind of combining them into one statement. And there's your answer for number 6. Or there's your answers, because there's 2 of them, right? So that's it. Like I said, this is going to be a quick homework. Just want to make sure you know how to solve kind of the basic ones here with the square roots. Also be aware of if you get the square root of a negative, that's going to be no real solution. And then know how to deal with these squared binomials. Either way, you're going to be using square roots throughout all these problems. And that's about it for today. So thanks for watching, and y'all have a great day.